Hey guys, my name is Ethan, this is Carberra. Welcome to the series where I teach you how to code in Python. Today we are talking about arithmetic operators. We're doing maths. Fun maths, as I said in the last video. If you missed the video on data types before, I recommend you go and watch that, because I am not going to be re-explaining differences between different data types in this. However, arithmetic operators have different effects on different data types. So you can, for example, do a string plus a string, but we're going to be talking about that near the end of the video once I actually explain kind of what the operators are. So, as a full list of the different operators you can get an addition, subtraction, multiplication, and division. So addition and subtraction, I feel as though should be fairly self-explanatory. Multiplication is an asterisk, but because just doing an x is going to be treated as the letter X, so we have a special character for that. This is pretty standard across most programming languages. And a division is a slash. If you prefer to think of it like a fraction, then you can do, but essentially it can actually be used in mathematics normally. Yeah, this is how you do division in Python. We're going to get an error there, but just ignore that. Some other things you can do are a double asterisk and a double slash. So this is to the power 2, and this is integer division. But I'll talk about that a little bit. I just kind of want to get through the list of things you can do. Again, ignore that error. And then you can have plus equals, minus equals, times equals, whoops, and then slash equals. So these will essentially do the operations and assignments in one line. I'll talk about that later again. And then we have the final modulo operator as well. So that's the full list of things that we're going to be talking about. I'm going to give myself some more room to play with. And we're going to be talking about the basic stuff first. So stuff like 3 plus 3, which is 6, or 3 minus 4, which is minus 1, or 3 times 4, which is 12, or 5 divided by 2, which is 2.5. This is fairly basic stuff with numbers. So you can do that with integers, you can do that with floats as well. So say 5.6 times by 6.7 is this. All these 9s and then a 6 at the end. Oh, my mouse has gone. This is an artifact of floating point division errors, or I think it's just floating point errors actually. I'm not sure they're technically caused by divisions implicitly. But this would normally be like 37.52, I think. Let's actually launch the Windows calculator and work it out. 5.6 times by 6.7 is, 37.52. So this can be somewhat inaccurate. If you want more accuracy with this, you could do round 5.6 times 6.7. I think I can't remember what the actual final thing is. It's just 2. There we go. So you have your sum in here, and then you have the number of significant figures to round to. I can't remember what the keyword argument is for that, but apparently you don't need it, so that's fine. But yeah, that will return 57.92. 37.52, sorry, I don't know where I got that from. But yeah, there are a few weird things in working with floats, so just be aware of that. You'll never hit that with integers, so if you do like 53 times 67, you'll get 3,551, and everything will be fine. Yeah, when it comes to strings, I did say you can add 2 strings together. If you do hello plus world, it actually stitches the 2 together. So you can add strings together, and it's a process called concatenation. So you're concatenating 2 strings together. So if I do, say, S1, for example, is this is the first half. And if we do a space, string 2 equals of this sentence. It's not quite half, but bear with me. If we do S1 plus S2, we get the full thing. So this is the first half of this sentence, which is technically a lie. Maybe not the best example, but I don't know. It makes sense in my head. You can also do strings plus numbers, or you can do strings times numbers at the very least. I'm actually not sure if you can do strings plus numbers. No, you can't. But you can do S1, say, times 4, and it will do, this is the first half, this is the first half, this is the first half, this is the first half. It will essentially repeat the thing as many times as you give it. So you could do S1 times 100, and you'll get this enormous string that I'm going to quickly get off the screen because that's very distracting. But yeah, as you can see, it just constantly repeats. So these are different. Yeah, these are different ways that operators can be used. Different data types have different funky ways of operating. Feel free to experiment if you want. But I'm going to be moving on to the next type of operators, which are the, as I call them, doubles, which are the double asterisks and the double divisions. So if you're not sure how either of those works, the 2 asterisk 5 is saying 2 to the power of 5. So you're doing 2 times 2 times 2 times 2 times 2, which is 32. It's fairly simple stuff. The integer division is a bit more non-standard. So what this is doing, if you do 5 times 2 is 2.5, is it's essentially returning an integer of whatever this would do. So you could argue that 5 divided by 2, or 5 integer divided by 2, is the same as doing int 5 divided by 2. Because they literally are the same thing. It's just a little operator to save you from having to do a conversion, because this is a lot more efficient in the long run. So if you ever need to do that, then cool. However, there isn't a specific one for rounding, so you will still need to do like round 5 divided by 2 if you needed like a rounded integer, for example. But those are those two taken care of. Now I'm going to be talking about the assignment ones, so the plus equals, the minus equals, the times equals, and the division equals. So say if we have, make some more space, say if we have a number which equals 5, and we want to add 3 to that number. Now we could do num equals num plus 3. That is perfectly valid, that will return 8. However, if we want to shorten that a bit, we can do num plus equals 3. And as you can see, we've added another 3 to this to num. So num is now 11. So what we're saying here, is we're saying that the number equals whatever the number is plus 3. What we're saying here is add 3 to number and save it. Pretty much. That is the difference here. And it works the same with minus equals. So if you want a minus equals 4, you can do that. And you can do num, which equals 7. If you want to do a times equals, say 7 times 9, you can have 63. And if we just kind of set num as like 60, for example, just so I can show off the division equals easier. If we do num division equals by 6, we'll get num equals 10. Now this does return 10.0. It does return a float. However, if I just set num equals 60 again, you can do the double division equals, and it will return an integer back out. So you can combine the equals with the single or the equals with the double. It doesn't matter. I'm going to quickly check if you can do this, because I actually don't know. Oh, you can do that. Nice. So you can also combine it with this to essentially raise num to the power of 5 and then save it back into num, which in this case is 100,000. So those are some pretty cool operations you can do. Those make things a lot cleaner and a lot simpler to use, and it's also a lot more readable in my opinion as well, because it's basically just saying just add 3 or subtract 4. You know, it's easier than just, this isn't really how we think, whereas this kind of is, at least in my opinion anyway. I could be wrong about that, but we'll just see. I'm not a psychologist. And then finally you have the modulo operator, or the percentage sign, which is quite special in the way it works, because if we do 5 modulo 3, it returns 2. Alright, what the hell just happened there? So, what we are doing there is doing 5 divided by 3, which is 1.6. So, if you think, essentially the modulo returns the remainder, more or less. So, if you do 5 divided by 3, you can do that one time, and then you have a remainder of 2, because 3 goes into 5 once, and then you have just 2 left over. This modulo will give you that figure. So you could, in theory, do like a string, for example, a string of 5 divided by 3 plus r plus a string of 5 modulo 3. And you have, oh, this actually needs to be an integer division. And you can see we have a 1 remainder 2. So we actually have long division syntax here. There isn't an inbuilt way of doing that. But if you wanted to do long division syntax, you could do this. So we have it's 1 full 3 goes into 5, and then we have a remainder of 2. So this kind of shows off like how to do all sorts of different operations as well. This is kind of like a final example. Not planned, but I think that's a pretty cool little thing. But yeah, that's pretty much everything I wanted to talk about in this video. There are plenty of other things you could do with operators as well, but in terms of the basics, these are pretty much all you need to know, I believe. If I have forgotten anything, because the world of operators is so enormous, then I will either leave it as a comment or I'll do like an episode 2.1 or something like that. But yeah, if you have any questions about what you've seen in this video, feel free to leave them in the comments, or you can join the Discord server using the link in the description below. While you're down there, I recommend that you check out my Twitter and Facebook and my library and all that stuff. All my socials are in there. And I also have a Twitch channel that is pretty new that I'm streaming stuff on. So right now I'm streaming the planning for the Pillow series. That's quite advanced stuff. It's not quite as basic as this, but if you do want to watch me code, or you just want to chat while I'm coding away, then feel free to follow me on that. I'd really appreciate it. But yeah, that's going to do it for this video. If you liked it, then say hello down below. If you really liked it, then consider subscribing and hitting the notification bell so you don't miss out on future uploads. And if you really, really liked it, then consider supporting me on Patreon. Of course, you don't have to, but a really cool thing of you to do. Then in mind, I'd like to thank all my amazing patrons for supporting me. And I will see you next time when we talk about logical operators. So I'll see you for that.